Hello, everyone. Thanks for joining me in this presentation. My name is Mike Reinhardt, and I'm going to be giving you a presentation from an inspired Kaggle competition that I recently participated in. So the title of this project is called Can I Borrow Some Money? So let's get into it. All right. So what will be covered? All right. I'm gonna give you a background of the data set, my approaches for data preparation, cleaning, and my exploratory analysis approaches, and the three different type of models that I use to train my data. And last but not least, uh, the stack method, which is also kind of known as ensemble learning, was the last model I decided to do uh, at the end of the whole model building process. So let's get into the next slide. Alrighty, here we got the introduction. So this data set is from an expired Kaggle competition that took place years ago. So the whole idea of this competition is to predict whether somebody is going to experience financial distress within the next 2 years. So banks, play a crucial role in the market economy, and they determine who will get some type of funding when it comes to loans, when it comes to anything that has to do with distributing money for some sort of purpose. So this is all solely based on credit when it comes to banks. They are the people that look at your credit when it comes to distributing money. And credit scoring algorithms play an important role to determine whether somebody is going to be in default or they already in default. So my goal here is to build a model that banks can use to make decisions on whether someone can get funding. So let's go to the next slide. Data preparation. So at first, when it comes to data preparation, I like to look at the structure of the data. I like to identify, uh, my outcome variable, the variable that I'm going to predict, and then I like to look at the data types to make sure the predictors are in the proper format that I want them in. As if, for example, if there's a integer variable that has values that are categorical, I would convert that into a factor variable for proper analysis. And then I like to go to my five number summary to look at the ranges of the predictors and to make sure there are like make sense and to make sure they are not at a extreme range to where it doesn't line up with the data really well. So let's go into our next slide. So here's a visualization of my model building process. It's very straightforward. I usually start my data preparation, cleaning, exploratory analysis, and perform cross-validation to minimize the mean square error. And the four modeling techniques I use and predict the test set and choose the best model, then submit my results to the calculus competition. All right, straightforward. All right, so we're about to go to the next slide. All right, so we got the data cleaning. So first, I like with data cleaning, I like to look at my predictors and to use the five number summary from the previous slide to make sure the values, the min and the max make sense, right? So I want to make sure there are no outliers or any anomalies in my data to skew the results when training my data with some sort of machine learning method. And usually I will replace my outliers with NAs and remove them because I don't want them to skew my results when training and predicting on unseen data. So let's go on the next slide. Exploratory data analysis. So first, when it comes to exploratory data analysis, I like to use a visualization tool. The two methods I would usually use are histograms, bar plots, and many more. But specifically for this calculus competition, I use histogram and bar plot. And I usually use a histogram to check the skewness of the data and to check and see if the predictor that I am plotting is normally distributed. And also for a bar plot, I usually check the counts between two groups for the target variable to see if there are any really extreme unbalances between uh, my outcome variable. And I'll usually do the t-test to test if uh, two means of that outcome variable uh, are the same. All right, so let's go to the next slide. So my first method for model building was to use a logistic regression technique. So the purpose for applying this technique is because my outcome variable has to be dichotomous, which means that it can only be two values, yes or no, or zero or in one. And it doesn't need to be linear like a regular linear regression model. And a good thing is that it does my data, my predictors don't need to be normally distributed for logistic regression. And so if you look on to the right here, my model performed okay. It wasn't as good as I thought for logistic regression. Performed at 74% accuracy with a kappa statistic at almost 49%, which is not too bad. It's at the moderate scale. And I had a AUC, which is 74%, which is not bad. It lines up with the accuracy, which means that my data is not being overfitted. But I wish it would have performed better than it did. But this is due because since the data was so unbalanced between for the outcome variable, I had to oversample. Um, you use an oversample approach to kind of balance the outcome variable because there was too many no's and and very low yeses. So I had to equate those, kind of make those kind of even, so my data wouldn't overfit. So, all right, let's go to the next slide. All right, for decision tree. So the reason why I chose decision tree is because that it doesn't require the predictors to be linearized or to assume normality. And another reason why I chose this classification technique is because it's inexpensive when it comes to computing. I know for XSVM, it takes forever to compute predictions. So with this decision tree, it was fast, it was easy, and it was simple to implement. So over here at the right, here's my confusion matrix, and I got an accuracy of 73%, kind of relatively close to logistic regression model that we saw in our previous slide, with a kappa value of 47%, which is on a moderate scale, which is really decent. And I got a area on the curve is 73%, which is pretty close to my accuracy. So this implies that the model did not uh, overfit or overtrain. And so as you can see that I have a lot of uh, mispredictions for both sides, yes and no. And this is because, like I told you in the previous slide, I had to perform a balancing technique to balance the outcome variable because it was highly unbalanced. So let's go on to our next slide. So right here we got k nearest neighbors. The reason why I chose k nearest neighbors is because I got a large data set of over 130,000 rows and 9 columns. So I think it was applicable and right to perform this classification technique on my data set. And also I like this technique is because it's flexible, right? It's flexible with the outcome variable, which means that the outcome variable can be either numerical or categorical. And in my case, my outcome variable was actually uh, numerical, and I just converted to categorical so I can it's can be read a lot better when it's actually showed on the confusion matrix. So if you go over to the right, a model didn't perform as well as I thought it was going to do, with an accuracy of 65%, kappa rating on a slight scale of 30%, and the area on the curve with 65%, which this implies that the model didn't overfit, but it did mispredict a lot of values. So let's go on to our last method of this presentation. Ensemble methods. So with the ensemble methods, I combine 4 different models: k-nearest neighbors, decision trees, naive Bayes, and gradient boosting, and combine into one stacking model. Uh, and the reason why I applied the ensemble method approach is because it reduces overfitting, and plus it reduces biasing. So my model performed very poorly than I expected. It performed at 53%, which means that this model could possibly guessing at this point, random at chance, since the kappa rating is at 5%. So this is really not a great model, and it performed poorly, and it did not perform as good as I thought it was going to be. And so I wound up picking a logistic regression model from previous slides, and we're wrapping this thing up. I hope you enjoyed this presentation. On my next slide, you have my contact information where you can reach me anytime about questions about data science, or you have any questions about this presentation. Feel free to check my GitHub out. And yeah, thank you.